So Java additional topics for FRC. And I'm calling this session 2, even though this is our third session after the break, as we actually started into our additional topics last week. And our topic last week was PID, how to get smooth operation of robot elements such as robot arms or turning the robot in this direction or that. And well, let's just jump right into this evening's session. Our schedule again, just seeing where we are. We're in kind of more of the advanced topics now, January, February. Maybe that's not the best word, advanced. It's all along a pathway. We're just moving further along the path. And last time, as you know, we talked about PID control, proportional, integral, and derivative. And there will be a little connection to the PID in this evening's talk and a connection to the future topics. And we see here 3 graphs that add to some smooth operation for the robot. And that's what we want to achieve, some smooth and efficient kind of movement towards a steady state. I would probably guess that this greenish yellowish curve, if my eyes serve me right, is the sum of 3 other curves, this square and these other 2 curves here, that gets us a relatively quick movement towards a steady state with a slight overshoot, but a very rapid correction. And that's what we achieve with our PID. Just double checking our chat here. Oh, we have a hello from Yana. Hello, Yana. And so in this session, we're going to look into the robot builder, which we will find on the WPI-lib website. And a reason why the robot builder is a good topic to put right in this session, we do have PID mentioned in the framework for robot builder. And at the same time, we look into what we call state machines, the command-based framework, which we talked about before the holidays, and pretty much all the other programming topics we have on our schedule. We will look at the process of dividing up a robot into subsystems. And then from these subsystems, we will generate or derive commands. So for example, one subsystem of the robot is just the drive base. And then another subsystem for this year may be the ball intake. And the third subsystem may be the ball shooter. And the fourth one may be the climber. So those are a few subsystems that come to mind. If you have a pneumatic module on your robot, that could be another subsystem. And then we'll talk about how to generate the command-based code for a robot using this graphical user interface, which comes with our 2022 version of the WPI-lib software with VS Code. This picture here is taken from the Robot Builder website, and it's just talking about the subsystems that I just mentioned. In this case, the robot has an elevator, and there's some kind of alignment device, there's a camera, and there's a gripper. 4 subsystems. And in addition to that, the drive base. And so those are the things that we think about when we talk about building our robot with Robot Builder. And we're referring to building our robot in software, even as we build our hardware in software, in hardware. And so the first sort of thing that we need to do in the process this evening, we're going to well, I guess it's the second thing. We're going to build a robot in the robot builder and then generate code. And we're going to verify the robot configuration in the robot builder, export the code, and study the connections between the code and the robot components. And the final step would be to get the code working, as it gives you a pretty good framework. There are a few extra commands you may have to fill in. And there's something called sequential commands we can look at. and there may be some other troubleshooting to get your code actually working on the robot. And one thing we might consider is taking this robot command-based code framework and somehow combining it with the simulator that we have from other times. The simulator then would allow you to test this new framework of code generated with the robot builder. So that's an overview of what we'll do this evening. All right, so we will now take a shift over to our VS Code. And I have here a whole set of code that was generated using the robot builder, but I'm going to start from scratch and build up a new robot using our robot builder interface right here. So let's take a look for the moment at our robot builder introduction that shows up on the First Robotics website. A very good thing to remember, and I'm sure many of you may have already done this. I've already talked to several of you about installing the 2022 version of WPI Lib. I did this afternoon. You may want to just go back up here to the installing software part of the website. And I looked at WPI Lib installation guide, and I went to GitHub. And from GitHub, I found the appropriate file for my computer. I downloaded the Linux ones, or the Linux file. You can download the Mac or Windows or whichever one you need. And then went through the installation instructions for my computer, executed those commands, and the installer now resides on my desktop. And I'll show that here. Oh, so many windows open. Didn't realize I had so many windows open. Wow, they were all hiding. Okay, here's my desktop now. And there's the FRC VS Code from 2021, and then the freshly installed one from 2022. And I'm not sure where that one came from.
How recent is that update, William? Is that something like if we've installed this year, should we still update?
If you've already installed it past January 8th or when, anyway, you should, maybe we can find a way to double check what is the version of the VS Code. Let's see what we have here. VS Code is here. 1.63.2, and I don't know if there's any mention of the WPI lib in here. Well, it says 2022. As long as you have the 2022 version, it should be up to date because we're only a few weeks into 2022. And if you're not up to date, you can always try this. Go to your command palette and look for an update. No WPI lib update found. So in my case, the one I downloaded off the website today was the one that we needed. So there it is, WPI lib, check for WPI lib updates. Okay. Now with this newly installed WPI lib, it does not require you to uninstall the other WPI lib, the 2021 version. They reside in folders alongside each other in the computer's file system. So that's all fine. Then we look at launching the robot builder. Okay, so here's the robot builder. If I just go back here, the robot builder introduction, and you can read through this at your convenience. It tells us a number of things. So whatever I speak about this evening is based upon and rooted in this guidance here on the website. And so what we're going to try to do is launch the robot builder. Starting the robot builder here has some instructions. Under WPI lib, the start tool is what we use to launch it. So let's try that now in our VS Code. I'm going to maybe try to close everything. Oops, I just closed the whole thing. All right, there's my WPI libs start tool. I recently used that. And under the start tool, it asks us to pick one of the tools here. There are numerous other tools that are very useful for testing out your robot code. I'm just going to go to the robot builder here, and it's probably going to ask me to do a new project. So what I should probably do is close the other version of it, just discard all of this, and let me make a name for this. I put my team number in there, 6162, and my robot builder project, that's the name for the project, and created the project. The text tends to be a little bit small, and I did not find a way to make it magnified. If someone knows about that, you can let me know. But I see under the view and the edit and the file, they're very sparse menus. It would have been nice to just show this a little bit more clearly. And anyway, here's our welcome to the robot builder. Also, the text here is very low contrast between a dark background and the black text. So we have to use our imaginations a little bit. This is a default tree of organized code in our robot builder project. It starts here with some subsystems and commands. I haven't explored all that much about the operator interface in the robot builder. But you can see that that has to do with the game controller and different things like this. And I'll probably look into that a little over the next week. What we'll do is just a very basic robot system. I'm going to imagine something like a simple robot to solve this year's game. And maybe just focus on one or another of the systems. Maybe an arm that would lift the ball up and then achieve a certain angle. And the reason for that is to be able to do a PID controller and a PID system in our robot. On the left here, we have a whole bunch of icons. And first of all, we can think about our robot in terms of subsystems. The first one I'll put in here, I'll imagine putting in a subsystem for the drive base. And let me just call that drive base. And is there a default command? Not at the moment, because I don't have any commands. I may come back to this. And should I send it to the smart dashboard? For the moment, I'm just saying yes for all of these. More information in troubleshooting is better than less. And there, I just created a subsystem for the drive base. In this subsystem, I can put additional components. But first of all, let me define one more subsystem. I'm going to make it a PID subsystem and drag it onto the subsystems folder here. And this one, I'm going to call this a PID arm. Again, there's no default command. I haven't added so many commands yet. So let me come back to the commands and edit them, send it to the smart dashboard. And then inputs and outputs, I also don't have so many of those at the moment. You'll see here there's P and I and D. The values from our PID discussion last week are incorporated into this PID system. And we also have an input and an output. In the case of an arm, you can imagine the input is perhaps the motor, and the output to see how we're doing, the feedback is on the encoder. The encoder tells us Are we close to a certain angle on the arm? There's like a rotary encoder on the arm, you might imagine. And when the arm moves through different angles, then the encoder counts up in corresponding or in proportion to the angle. And so when the encoder reaches a certain level, then the robot is or has its arm oriented in the correct way. That's our input and output system from in a PID subsystem, I suppose. Okay, so I'm just imagining a very simple robot with a drive base and a PID arm. And in there, we're going to have some motor controllers. Here is a motor controller. I'm just dragging and dropping. You see that it won't allow you to drop it just anywhere. I'm going to drop this right onto the drive base. And it becomes motor controller 1. And now what kind of motor controller? Well, I'll imagine my robot from last year, we had talons. Let's see where we have Talon SRX, SPX, or Victor Talon SRX. There we are. And the output channel is 0 by default, and you can choose to invert it or not. Sometimes you have to do that to get the robot working well. And I'm seeing the motor controller here. I'm going to call it the same. It's good to have the same motor controllers on the same subsystem. And we'll just continue with that. The third one and the fourth one. There, now I have 4 motors on my drive base. Another thing that I had, or that we had on our drive base in previous years was a sensor, an encoder. It was actually a quadrature encoder. So we could put one of those in the drive base, maybe actually 2. We had one on each side of the robot in our particular configuration. And these encoders tracked how far the left and the right side of the robot had traveled. And there we might see or consider one subsystem, the drive base, consisting of some encoders and some motor controllers. Beyond the motor controllers, of course, are the motors, but they're not directly tied with the logic of the computer programming, as the computer program interacts with the controllers. Okay, let's look at our arm now. And in our arm, we would probably have 1 or 2 motors. Let's pretend there are 2, just for fun. So we'll put 2 motor controllers in there. And I put them in like this. As I'm speaking, I'm just making sure because as I was speaking, I was not completing my previous task and converting all of those to the same type. So that could be an issue, making sure they're in the same type of motor controller, the talons. I just thought of that because in here I have my PID arm. So I'm going to name these motor controllers a little bit differently. I'll call this arm motor controller 1, and let's just pretend it's a PWM Victor, and the output channel is 4. This is pulse width modulation. I'm assuming we're using the regular PWM channels of the Roborio, as opposed to the CAN bus. All right, and then motor controller 2, in a similar way, we'll call it ARM motor controller 2. And I'm using a Victor for those 2, and they're occupying channels 4 and 5. Okay, and with our PID arm, maybe we need some kind of encoder as well to see how far up the arm has moved. Let's see, we could have, oh, that's interesting, an analog potentiometer. That could serve just as much as an encoder. In fact, since we're only imagining going through a certain number of degrees, maybe I could have that as my sensor in the arm. So you would just design some kind of way that when the arm moves up or down, then this potentiometer turns, much like an encoder, and you can measure the resistance on it with some circuitry and some study of how the resistance changes between the pins as you turn this dial or knob. Okay, this is all just for example, and on your robot, you may have a different configuration, though this one gives a reasonable example. All right, now let's imagine some commands. We've got a default autonomous command there. And well, let's make a new one. If you see that I've right-clicked on the commands button and I can add a command, add a PID command, add a sequential command, and so on. So here's a command. And instead of calling it command 1, maybe this one we can just call it drive, because we're going to drive our 4 motors. There we are. And our drive base may then take on a default command of drive. Now I have that as a choice. So there's my command drive. Again, sorry for the contrast. And then once I make the command, I can go back to my subsystems and associate those subsystems with the command. Okay, now the ARM. I'm thinking back to the 2019 and 2018 games. Our team ended up doing state machines for several of the subsystems. And in particular, the ARM was a very successful state machine. The ARM would open up, and then the robot would move around one of those power cubes. And then with one button, we could have the ARM close, and then the elevator would take the ARM up, and we would move the power cube in place in preparation for placing it on the scale. So I'm going to imagine a command, which is a sequence of other commands, something we use in a state machine, and I'm going to put it on this PID ARM. Oops. Oh, sorry, it's in commands. And we'll call this, instead of, well, this year we're not grabbing a power cube, we're grabbing cargo. And this is a sequential command, and there may be several other subcommands for grabbing the cargo. All right, and oh, can it be used in autonomous? Why not? We should have that available in autonomous because that's what happens sometimes. And the ARM cargo, it depends on the PID ARM, and I should take a look here on the drive command and say that it requires the drive base. Okay, so there's grab cargo, and right now it's going to be an empty command. I'm going to imagine a few subcommands now for this grab cargo. Let's see. Here's just a standard command. And this one, I can imagine we can call it lower the arm. And sometimes that just requires a little bit of gravity. You make the motor go backwards a little and let it just fall down. In other cases, we had an elevator on some roller chain, and then we had to just run the motors in reverse. So maybe I'm just going to imagine some roller chain lowering and raising this arm. And let's see. Requires our PID arm. And there we are, a few parameters. We'll just imagine that first the arm lowers. And then another thing that will happen is on the arm, maybe we'll collect some other things. So as to keep it simple, we can imagine another subsystem for the intake. I'm just going to imagine the arm at the moment, and we'll have a PID command for raising the arm. And maybe I could have done a PID command for lowering the arm. We can just make that depend on our exact robot design. So here's PID raise arm. And what's it going to require? It's going to require the PID arm. And it's going to have an input. So the input is going to be one of the motors. And I see here, we don't have a motor on this arm now, do we? Arm motor controller, yes. Oh, I guess it just wants the encoder, okay. So we'll call this the analog potentiometer, and the output here is going to be the motor controller 1 and 2. Oh, it only does one at a time. Okay, let's just imagine the one for the moment. So there may be 2 parallel commands there, raising the left side and raising the right side. All right, so I have something for lowering the arm, and I have something for raising the arm, and we'll just keep it simple at the moment. Your actual setup may be quite different. And when we generate the code, then we can imagine we're going to have a grab cargo command that first lowers the arm. Maybe it waits a few seconds while the other subsystem intakes the ball, and then it raises the arm, something like that. So maybe we could have like a command like wait 3 seconds. Oh, that's timed. Okay, why not a timed command? Wait command. I'll call this wait for intake. Okay, and it requires, of course, the PID arm subsystem, and that's good enough for now. Okay, so you can see if you take a little time, you can come up with a whole bunch of the systems in your robot, and this will be very helpful for generating some command-based code. And you'll see in a moment here just how much code this is, or how much coding this is going to save. First, I'm going to verify that the robot is valid to export. Your robot is valid and ready to export. Now, that may not be true depending on what you want to achieve with your robot, but whatever has been done here, it seems to be valid. And if you don't get the whole thing exported, then you can continue the rest of the process in VS Code. All right, so now I'm going to go to Java. Project successfully exported for the first time. Open the project directory in VS Code. And that was quite something, very, very quick. Now, let's go to VS Code and see if we can find the robot project. File and open a folder. RobotBuilder project. That's the one that was just finished here. And here we have our robot code. I guess I have to trust the author because I wrote it. If I can't trust myself, I shouldn't be on my computer, I guess. Oh, it looks like it's building. And build failed. Oh no, let's see what it wants to say about the build failing. There are 2 issues in this file. Let's see what they are. PID raise arm. The constructor is undefined. So there may be some extra coding that we have to do to get this whole project finished. Oh, and this is all on the Smart dashboard. It may be that I have to define these on our Smart dashboard. I'm wondering what happens if I just do this. Is it going to be okay with us? Yeah, there are just a few warnings up here, probably because this one is not being used. It's just a sample command. All right, so I just simplified the code a little bit here. There may be a few other things here that are not working. The PID arm subsystem in the subsystems folder. Let's see what it's telling us. Oh, at the moment, I don't see any errors, although it is showing red there. So there may be some additional.
It's further down.
Oh yeah, there it is. PID source and PID output. All right. I'm just going to see for a moment if we happen to cancel those. oh, it gives us 4 warnings, but it does not give us any errors. And now there's an error in the commands here, the PID raise arm, that's way down here, a new PID controller. So there's something missing with the PID. We're not going to really emphasize the exact troubleshooting for this session. We'll probably do that in the next session, see if we can get this whole code working. At the moment, let's just take a look at our project and what we just created. And going back to our subsystems, we created the drive-based subsystem, and we have the imports of the various parts of our drive-based subsystems. Subsystem base, an encoder, motor controllers, and there's the PWM Talon SRX. And this, you'll see the default one is not used, and this live window is not used because I haven't specified certain parts of the program that might use the default motor controller or the live window. But this one appears to be used, and we'll see what it looks like down in this drive-based subsystem. So we define motor controller 1, 2, 3, and 4. And we define 2 quadrature encoders. And there are the 4 motors being assembled here. Motor controller 1, and it does all the syntax for us. This would have been several searches on WPILib and a lot of typing and a lot of copying and pasting or something of the sort, but it's all done here. So this robot builder is going to save us a lot of time. And there's our encoders defined in the same way. And it's in a sort of a programming pattern that I don't remember from before, this add child. I do not remember it from a previous time. So this may be an update or a pattern that I just haven't seen yet. But there we are. There's the drive base, and all of the parts of the drive base are defined for us. And now we have to decide what we're going to do with the drive base once we get everything defined. So it hasn't solved our whole programming problem, but it definitely has got us a fair amount of the boilerplate code prepared and saved in various files. Yes?
What were we going over now?
We're going over the connection between what we just generated in this robot builder and all the code that shows up in VS Code. So
okay,
I'm sort of emphasizing that it's going to save you a lot of programming time, but it's not going to solve all of your problems. It's just going to get you a good amount of the way there. From here, you have to define what's going to happen during the periodic time, the simulation periodic, and so on in the drive base.
And what is the robot generator thing called?
So this is called Robot Builder. It looks like this, and we find it in our VS Code just by the command palette and start tool. And there's our Robot Builder.
Oh, wow.
So
that's one of the tools that you install.
Yeah, it comes with it.
Yeah.
It turned out that my 2021 didn't have it there, or one version of VS Code didn't have it, but the one that I downloaded today, it definitely has it.
Are you using 2022 now or still 2021?
I'm using the 2022.
Mike pointed out that there was a new update on January 18th for the 2022. So
oh, excellent. Okay.
I just updated mine, and it seems to has some new things in it. Yeah.
Excellent. So that's good to keep up with those updates, because sometimes they solve critical issues and or may cause you to, anyway, it's just good to keep the whole project updated where possible.
I have a question. So this creates a command robot rather than a timed robot, right?
Yes, indeed. And that's the trade-off.
Right. The time seems nice and clean, and everything's in one place, and you're not jumping around, making sure that everything's got alignment.
And I think the command is kind of a natural extension of the timed. When you're just starting out and your code is relatively simple, then everything can fit manageably in a single file. and then your timed robot is the best choice. As you grow more systems on your robot and try to do more things with your robot, then your code base will get fairly long, and then it makes sense to subdivide it in this way.
If you have one-
Sorry, one of the
Go ahead.
advantages of the command-based robot is that someone brought up about autonomous, is that you can take a bunch of these commands and put them in sequence or in parallel as part of your autonomous. You just would call them as, I want to do this, I want to do this, I want to do this, because you've already created the commands, which makes it, as William is explaining, a lot less complicated as your program gets longer and longer.
Rather than say copying and pasting, Paul, like into the creating a whole set of code just for auto.
Yeah, so then that avoids if there's a change you have to make at an event, for example, you can just go to that particular command and make a change, and then wherever that command is, it's going to implement that change, right? As opposed to then trying to search through a ton of code to find out what it is that you want to change.
And have to change it twice, once for auto, once for periodic.
Or whether it appears in many places, like sometimes it does, right?
Right. The other question I have is, when you build with the robot builder, do you, in order to be able to call something to your Xbox controller, you have to have a command assigned to that, I'm guessing?
Yes, and I didn't emphasize in this session the controllers, and in a future session we'll do that. However, let's see what we have here. There we are. There's an Xbox controller, and I'm sure we can put this in one of our subsystems. I think it has to go in. Maybe we have to make an OI subsystem.
What does the OI stand for?
I think it's output input or something interface.
User interface, no? Oh, UI?
Yeah. Oh, operator interface, there it is. It was right there. So there's the operator interface. I just put a controller in there. And then when I regenerate the code, it'll have all the definitions for our controller. And since it'll be in our code, then when we go back to our code base, we can connect these commands and subsystems together with input from the game controller, for example. So maybe the start of the command is called when we press the A button, for example. And here's our grab cargo command. And similar to what Paul just said, not only with autonomous, but here's my sequential command group. I can just call the other commands that were made up in order. So first I want to open or lower the arm. Then I'm going to wait 2 seconds while it collects the ball. And then I'm going to raise the arm. And it can happen right in here. So that hasn't been done for us. I haven't found a way for that to automatically be done in the robot builder, but once we have the other commands, then this lower arm, we just say lower arm and wait 2 seconds or wait for intake, for example, and so on. And what's the command here? Wait for intake. And a timeout. So wait for intake for 2 seconds. That's kind of fun.
I think that those wait for that you're looking at are brand new in the newest VS Code. So, but you would have seen in if you put your joystick or your Xbox controller in and you just verified and then went to Java again, that it would show up. Now it's going to show up being declared in the robot container, which is where all your motors and stuff get put as well.
Yeah, let's take a look at our robot container as we're speaking about that. Our sendable chooser is a very nice set of choices that we use for the autonomous routines. Our dashboard is in here, importing the commands. And what else do we have here? Oh, we defined our ARM and our drive base. There's the subsystems. And look at that. It's all auto-generated. And it's all commented, so we know what's going on here. Oh, there's an empty spot here where we have the joysticks that would have been declared had I put one in there. And Down here, oh, look, we're putting onto the smart dashboard, we're putting various commands that we'll be able to see in our sort of interface. And we'll look at that in a future session. All right, so that's something that you might want to explore, this code base that is generated by this robot builder program, and play around with it and see what you can get going. And the decision you may want to make is, well, you can always do this in a timed robot. It's just that this one will allow you to do a command-based robot with a lot more organization on your code. So it depends on what you want to achieve. And it's something well worth trying out. On our team, we tried both command-based and timed, and various students did the command-based and timed for their projects in our computer science class. I see Yana has a hand.
Yeah, sorry. I was just wondering, can you go back into, like it said that it built it the first time, but can you go back into the robot builder?
Yeah.
And rebuild?
Oh, let's try that. Okay. I'm going to just close down VS Code so as not to confuse anything. And as you see, I put the joystick in there. Maybe some other things we could put in here.
Let's throw in a camera.
Okay, where is our camera here? Actuators, sensors, gyro, quadrature, limit switch, accelerometer. Wow.
Is there no Limelight available here or no?
I think a Limelight is a proprietary kind of device, and you may have to use the Limelight's documentation to put it in there. Analog input, digital input. Maybe we'll call our camera, maybe it's a digital input. And where is it going to end up?
For some reason, it's not like most FRC teams use like the same Limelight.
Ah,
I never knew there were like different types of them.
ours was not one of them. We used a system that was completely custom done. The trade-off being it took us a few years to get it actually done for competition. And then we never got to use it because COVID hit. But it was quite something. The drive base, I'm going to add another subsystem here and maybe call this the camera subsystem, as I saw that in one of the examples. All right, may as well send that to the smart dashboard. Okay. And in the camera subsystem, then I can put a digital input, which is probably going to be our camera. I don't know if that's a digital input. Maybe it's an analog input. I haven't thought about that too much, but it's some kind of input, and we'll have to look at the documentation. Maybe we'll just put an analog in there just for fun. Call this camera 2.
What's the difference between a analog input and a digital input?
The electrical signals in digital are organized in ones and zeros, whereas in analog, it's the amount of voltage which represents the signal. And that voltage can vary. And so the analog is a continuous signal, and the digital one is a sequence of rapidly changing ones and zeros. So the quality of the signal is a little different. So it's something well worth investigating the difference for. And since I didn't find the camera, I'm just putting both of them in here. And we can research what the camera actually would be. Okay, so we have a camera there and we have a joystick. Let's see what these look like when we generate the code. And I just pressed the Java button. It didn't give me any feedback.
Yeah, it's done it, William. So you could even have left the VS Code open down there beside the icon that you have, and it would have updated it. The only thing is,
oh, go ahead.
The only thing that you'll see where you pointed out, it says begin auto-generated code, and it has that all over the place.
Yeah.
So if you change something in there, when you regenerate the code, that will have disappeared. So that's one of the things why it says don't put anything in there. But you should, if you go to the robot container C. Well, there you go. You've seen your cameras created it.
Nice. So all the things we just put in there have been in
Yeah.
updated in the code. So
That's
that saves
That's really cool. Yeah.
hours. Yeah. And it's nice to know that you don't even have to close VS Code. I'm just so cautious from things being confusing in the past. I just try things in the easiest way where less can go wrong. That doesn't always stop things from going wrong, but I tend to do that. Okay, there we have our robot code being updated by the robot builder, and it looks very nice as it is able to save us just hundreds of lines of code and do the boilerplate for us. So what we'll focus on in a future session is turning this boilerplate into something that would be ready to deploy on a robot. In this case, we'll have to sew together some of the loose ends and make some actions for autonomous and or teleoperated, for example, and just do a little bit of work putting commands into our state machine, for example. And in fact, those are all of the topics for the remaining sessions. So we will continue in our robot builder for the next little while and do that. And maybe we'll have a few side examples in a timed robot that would be similar. Okay, so you can see here our PID. It relates to what we did last week. And one thing that might be an interesting challenge for you to try is to create or import a gyro and try to recreate last week's code in this week's framework. And maybe that's what we can review next week as well. Some places for you to do a little bit of investigation. I'm going to stop here as there is a lot to do. I just hoped to get everyone sort of started for this evening. And if there are any questions, very glad to answer them or at least address them later, depending on the question. And we will probably end our call in about 7 minutes just to be ready for the ReadyBot call, which will start at 8.
So like the way that you generate code from like the robot builder to Visual Studio Code, what button do you press? Do you press like the Java button?
Yeah, actually the first time it gave me feedback. That's why I was a little confused. The second time it just executes it and writes it to disk without you even knowing. So that button right there, it updates the code instantly. So whatever you have here becomes the code in the command-based framework.
It would be nice if there was some feedback. You're right. That kind of threw me off too when I saw
Yeah.
it. The other thing I'd say, William, is that if they look through that, the original thing you had up from on, I forget what is the 2022 site.
Oh yeah.
It does have some videos in there that, or some screenshots that might be helpful, right?
Oh yeah, this whole thing here is great to get started. It's what I used to learn about the framework. And it seems to be doing a different interface. I don't know if they have a different theme or if this is last year's interface, but anyway, these pictures are more easy to see.
Well, mine looks just like that today.
You can
so
change it in your, if you go
it could
into
be my theme. Maybe I just
It
have
is,
to have
I think.
a brighter theme in my
Yeah.
VS Code. I should try
Yeah.
that.
Before we end tonight, can you
Yeah.
just briefly, I know you said you'll mention it later, but just so we can do some learning in advance, what is the smart dashboard and state machines, just in a nutshell?
Okay, so the smart dashboard is an interface for the robot that gives you feedback. I think there was a picture of, there's Shuffleboard, an example of the smart dashboard. I don't know if that, oh yeah, there it is, smart dashboard. It is something that you can use to interact with your robot. So we click the place button and it places a cube or something. And now it picks up a ball and it opens the claw and closes the claw. It's just a graphical user interface. And it's written, as far as I know, at least one of them is written in Java FX. And that's why we did Java FX before the break. As if you want to work with your shuffleboard, maybe you can modify it in Java FX. So that's the shuffleboard and or the smart dashboard. It looks like this and gives you feedback about your robot, and it can be customized. You can put different elements in there, widgets, as some of them are called, to get real-time feedback. Some of them have little gauges and dials, and it's just like a control panel for your robot. Now, the state machine, we actually started alluding to a state machine today. If we look in our commands, where's grab cargo? Grab cargo is designed to turn into a state machine right here. And the state machine is a sequence of commands, each of which finishes and then the next one starts. And since this is designed as a sequential command, the system will know when one command is finished. So for example, maybe I just let my arm fall down. I'll reverse the motor for half a second and gravity will take it down. That happens on some robots. Then I do something for 2 seconds. When it's done the 2 seconds, it returns control back to this list of commands. The next one is raise the arm. Maybe we raise it in PID to get it exactly where it needs to go. All right, so those are 3 commands that start in sequence and end when a certain condition is met. Either the time is up, or a sensor is tripped, or the PID condition is met, and so on and so on. And so that's the state machine. And so we've made some progress towards making a state machine. We just haven't made one yet. Hopefully that will get a few things to look at for you in the next few days. And you'll see here, let's look at the, oh yeah, there's shuffleboard to test a command. And then we also
You're not sharing your screen anymore.
Oh, so sorry.
It's okay. Just you look like you're looking at something.
I was just sharing here a few of the parts in the WPI lib website here have things that you may want to look at. There's a little bit of a primer on command-based programming. The smart dashboard also uses network tables in some cases. You might want to look into there. And where is, oh, we've got the driver station. There's starting a custom dashboard. So there's references to the dashboard throughout here. I wonder if we can look it up on here. And what does that give us?
What is LabVIEW? Like the
Oh, LabVIEW is a visual programming sort of drag and drop programming language. It's used in robotics and automation. I believe it's done by National Instruments. And it is the language that my team did on the first year that it was in first. And then we tried a new language every year. We've done all the languages available now that we could get a hold of.
Oh, you even did C++?
Yeah, we did a little bit of that last year, but in practice, we've done mostly Java and a lot of Python. So there's our few articles on, there's the dashboard, Roborio dashboard, and so on and so on. Some of these, the driver station custom dashboard. Anyway, lots of references to the dashboard here, and you can take a look at them. Not all of them are relevant to what we've talked about, as it's used as a word in several contexts here. All right, I think we will conclude our call here for this evening.
I have a really quick question.
Sure.
When in the VS Code, when it actually creates, after all the subsystems through a command-based robot, is the robot.java file still where the executables are for timed and or like for auto and teleop?
Oh, like when you create the VS Code, like to actually start it?
Yeah, like when you, like for the actual, when it creates the code in a command-based robot, is there still a kind of home file where it actually, that's what you, where it has a switch or whatever between auto and teleop or whatever?
Well, that's done in the driver station, so it will be taken care of. Once you've got it loaded in the robot, you won't be able to tell whether it was a command-based or a timed robot, because the driver station allows you to select auto or select teleop.
So what's in the robot.java file on this in the command base?
Oh, the robot.java here is just sort of a container file that gets us started with the overall.
It just imports stuff and that's it,
Yeah.
basically?
In this case, it's we've got the autonomous periodic, the teleopnit. Maybe that's what
Okay.
you meant by your
Yeah,
question.
that's what I meant. Yeah, yeah.
Oh, okay, good. So that's
Okay,
all
cool.
still there, and you can, once you've got these commands, we can, there's
Pull
an
them in.
example.
Okay. Yeah, perfect. That's what I was wondering. Exactly. Thank you for showing me.
No worries. So have a wonderful evening, and we'll look forward to
Are we
seeing.
staying here on this Zoom or are you sending out another link?
There's another link that was sent in the email. Maybe I'll try to copy and paste it here.
Okay, thanks.
Just give me a moment.
Thanks. That was really cool. I'm gonna play with the robot builder.
Excellent. So see about this link here. There we are.
See everyone next week.
So take care, and just leave this on for a moment to show you the Zoom link. And we'll look forward to seeing everyone very soon. Thank you. So this link I just pasted is for anyone who has signed up to the Everybot.